right. So first off, I gotta show you guys some sick thing. All right, that is my live computer. That is what is happening at my desk right now. So in the future, in the future, when I need to go solder something, I don't need to bring the soldering iron out there. I just need to go in there, and my stream will capture all of that. So it's just part of the process of documenting the making process so that nothing is left out, because that's really the thing that grinds my gears. But that's not really what we're up to today. What we're up to today is we're going to be finishing this design, and then we're going to be designing a feeder, which I basically haven't started yet, which will go here, and then this fly will be on both of these things, and will push a ball into it. Now, I'm starting small because I've been trying to conceptualize the design for this and just having a hard time with how a servo will push it in. And so I'm not going to jump the gun and try to do something with a hopper and a servo, because I don't know, it just seems like too much changing at once. Yo, what's up, man? Early in the morning, what's going on in Poland, dude? It's a cold day here. It's supposed to be high of 73. It's been like 85 or 80 every day, and sunny, and it's been great. So we're starting to get into the cloudy, kind of gloomy weather. It's flooding? What? That's terrible. I forgot what town. Dude, I should write this down. What town are you? What town are you in? Wait, can't spell. Oh my god. Dude, I hope you're safe, man. Oh, you're in Warsaw? I thought you were why did I think that you were like in uh a different place? I thought you were in like outside of it or something. It's not flooding there. Oh, well, that's good. Lods. Okay. What was I gonna do? Dude, that's scary. I've never been in anything like that. The hardest rain I've been in was in Spain. And it was kind of scary. Like, we had to pull, because the thing is, it was hailing at the time. Man. That's awful. Okay, so what are we doing? We are modeling 4 parts. So, okay, wait. The high level thing is we're finishing this, which is going to go on to this. So we're switching from 2 axes to 1 axis. So instead of having this whole thing, which oh wait, this I should probably just delete. These 2 things are totally useless. So this is what I had before with these big motors, and now I've switched to these motors, which luckily I was able to find on CAD. So I was able to find a I'm pretty good. I feel like I'm a little stuck the past 4 or 5 days in this project. I did this cool thing. I don't think you tuned into this stream, but I took this thing called a AS. It's called a magnetic encoder. Let's see if there's a picture. Anyways, it's this little chip that can take what's called a diametrically polarized magnet. So magnets like circular cylindrical magnets could be polarized in two different ways. One just straight down the middle. That's called axial. No. That's called diametric because it goes along the diameter of the cylinder, and then axial, which is the other way, which is like cut in half. And so you need a diametrically polarized magnet. And then as you rotate it, so what you do is you then glue that to some part of the rotor of the motor. So the part that rotates. Um, wait, MRI? What does that mean? Um, and so you glue this thing to the bottom of the motor, and so the magnet will spin as the motor spins, and then the sensor will pick up the angle of rotation, which is really freaking cool. Dude, magnets, I honestly don't really get how they work. Like permanent magnets, I can kind of understand how an electromagnet works, but a permanent magnet, it's like spooky shit, man. Now, anyways, I don't know if you've seen that. There's this thing, Insane Clown Posse, magnets. How do they work? Anyways, I'm not gonna play that. Um, so that was really cool. So we were able to get so uh nice. So we were able to glue it, and we were able to get an estimate of basically how fast the motor is moving in revolutions per minute. The problem is, as you turn up the throttle, the readings get less and less accurate. So I don't really have a good estimate for how fast I can go at max throttle. Luckily and unluckily, at max throttle, I found out one of the motors was stalling on me, um, which is kind of unfortunate. Uh, because so I switched motors. I don't know how much context you have. So I had these originally, these 775 DC motors, and these things were very heavy. And they are pretty good, but they're brushed motors. So it's not really an issue, but but anyways, so I have two of these, and um the problem is they were too heavy. And so in this assembly, this whole thing, let's see if I actually have this work. Okay, so I didn't get it to work, but wait, hold on. Wait, I can just probably go to the joints. Is it this? Okay, I don't know what's going on. But anyways, this whole thing rotates. I set it up wrong, but this thing rotates like around. And the problem is that these motors, this motor could not lift this assembly, even with the gear here. Oh yeah, there's this random thing. Okay, even with this gear reduction, I still couldn't get this thing to lift up with the motors, unfortunately. But these motors are much lighter. I think based on the footage that I have that um so the face tracker, okay, wait, let me just finish this thought. Is the these motors, based on the footage I have, I don't think they actually shoot the ball as fast, unfortunately. But um they are much lighter, so that means I won't have to upgrade these motors, which I kind of want to do anyways. But the problem is I'm sort of space constrained because my 3D printer can only print like 256 by 256 by 256 millimeters, so 25 by 25 by 25 centimeters. And this thing caps out, like the diameter of this top circle is literally 250, so I only have like 6 millimeters more, and you can't even really use those 6 because it gets so close to the edge. So the problem is, you can see that this motor is already sticking over the edge. And if I were to upgrade motors, this thing would be like, its center of mass would be, if it wasn't screwed in, it would just fall over, which is honestly not the best. So I kind of want to buy the motors anyways. I'm just like sort of tempted. You want to just hop on, you can just hop on Discord. I'll walk you through it. If you're not busy. I haven't been on. I mean, I feel like I haven't chatted you in a while. I'll just hop in my allow on every visit. Oh wait, you're not in here anymore. Do you need an invite? I think I have a permanent invite somewhere. All right, so you'll probably have to mute the Twitch stream so that you can and then I need to turn on this. Nice. Yeah, I noticed that you were gone and I was like, "Oh no, man, my favorite, left."
Yeah, on channels, I had like 50 or 60 of them, so I guess I
Yeah.
accidentally this one.
It's kind of
Now I have
weird
like,
that they only limit you to like not that many servers.
wait, what?
I,
Is there a limit? I
I'm
mean,
pr
I had like, I don't know, probably 50, 60.
I think I remember I had to go back and because I was just joining like everyone's Discord, and I remember at one point they said you cannot join anymore.
Oh God.
Um,
No,
any
it never happened to me, but I feel like 50 is too many anyway.
Yeah, I know. I need to drop it because I mean I don't check like any of them. Um, uh,
Yeah, same, same.
yeah. Okay. So wait, you asked the question though. Is how is it related to the face tracker? So the face tracker is actually kind of a separate thing. There's sort of two projects that I want to build out of just like the modeling that I'm doing. One is just like a very small like thing that can sit on my desk that when I stream it will follow my face as I move. And that's like a small thing. And so that's why I was sort of interested in just like face recognition. But this project doesn't actually need face detection because what I'm going to be doing is I'm going to be shooting the balls covered in paint at a canvas. So I'm going to try to render an image onto a canvas by shooting paint covered Nerf balls.
I've seen, I think I've seen it somewhere.
You have? Because I was trying to look for something like that, and I've seen people use a paintball gun before, but they haven't done it robotically. They just used like a paintball gun by hand. And then there's two other videos on YouTube that I found related to like automated painting, but I haven't seen anyone use a gun. So if you can find that, I would painting with a gun. Let's see. Can I find actually a painting robot?
Yeah, actually, I found it on the NVIDIA channel 14 years ago.
Wait, can you send it in the somewhere?
Yeah, yeah, I sent it.
Oh, it does. Okay.
It's 20 seconds in first 20 seconds.
Wait, no way. It's MythBusters? Oh wait, NVIDIA.
Yeah, and it's on NVIDIA.
Oh
Yeah.
wow. No way. Okay, I can't believe I haven't seen this.
In the way that a CPU might do it, as a series of discrete actions performed sequentially, one after the other. In 3,
And this thing
2,
moves.
1.
Yeah.
Oh my gosh. Okay, so this is dude, I'm so glad you sent this to me. This is so freaking cool. Yeah, so I basically want to build this. Oh, I'm so glad you. Oh, and what I was gonna render first was a smiley face too. That's so funny. That's incredible.
Leonardo.
I mean, looks cool, I guess. Like, not that useful, but
Yeah. I mean, it's
really
cool
nice.
though. It's mainly just to see if I can do it.
Goes through these accumulators, out
Yeah,
these
yeah,
valves,
yeah, just
through
make it
all
fit real
1,100
bullets and
of
you got
these
it.
tubes, into these tubes in which the bottom of is a paintball. Each of those paintballs will fly across 7 feet of space and in 80
my God, this is
milliseconds
the
reach
coolest
its
thing
target.
ever.
Hopefully, when it's all said and done, it's going to paint the Mona Lisa.
No
GPU
freaking way. This is so
painting
cool. I can't believe
demonstration.
I've never seen this.
In 10, 9,
8,
7, 6, 5, 4, 3,
One shot, that's
2,
insane.
1.
That is so good. I wonder what
Ladies
resolution
and
it is.
gentlemen,
Do they say?
science class is now over.
I mean,
That is,
it's slow enough that you can count it.
yeah,
Like,
I could count it. Yeah. I mean, it's probably on the order of like
like
50 by,
40 by 80 or
yeah,
something.
exactly. Okay, wait, that's incredible, dude. The amount of work that went into aligning and putting all these barrels and stuff like that is so, and the colors too. Oh man. Wow. Oh yeah, okay, I get why it's CPU versus GPU. Yeah, that's so fun.
In the way that a CPU
Because,
might.
yeah, right,
As a
okay. I wasn't listening to what
2,
he's saying.
1.
All right, so I'm building a
Yeah,
CPU
me.
one. I'm not building that GPU one for sure. That's
I
way
find GPU ones kind of lame, honestly. They just size, sheer size. That's it.
I mean, no, but come on, you gotta admit that thing is pretty badass. Look at how much engineering went into making. I mean, I agree with you that it's like, what are you gonna do? Like compared to the size, like look at how small this is compared to like the massive monstrosity that this is. But
I mean, what I mean is that you can't just reprogram it and paint
wait, sorry,
something
there's a car
else.
going by. I couldn't hear you. Hold on, can you say that again?
All right. I said that it's not that cool because you can't just immediately reprogram it in seconds and paint something else. Like,
Yeah, right. That's a good
how
point.
long would it take to change the image for the first like CPU one, right? It would be like 20 seconds if you write the software.
Yeah, right. Yeah, for sure. Um, right, because it's literally, I mean, yeah, you need something that generates the G code, but the path planning there is not like all that hard. I would say this one, like, well, for one thing, the other thing that one does that's cool is the colors. But I wonder if someone had to like manually, yeah, because I doubt they have an automatic loader. You know what I mean? Like, I feel like someone had to like put the bullets in.
Yeah.
I mean, look at those. Look at that
Yeah.
Without
pressure
these
chamber too. That is an insane. Yeah, but I want to definitely look at this one because this one is a much more. Uh,
It just makes more sense.
yeah, it totally makes more sense, especially because there's just no way in hell that I'm gonna build that thing. This thing probably cost like $100,000 to make, if not, you know, I wouldn't be surprised if it was in the 6 digits. Whereas this, I can imagine you could build for like $5,000.
Wait, why would it be so expensive? I mean, I don't know about the price of that, like a pressure thing on the back of it, but the tubes themselves, they cheap.
Yeah, yeah, I mean, I don't know.
We
Stuff
need
seems
the
to add
weld,
up.
right? The pressure gas.
But no, yeah, I that's just an upper bound. I agree with you that it's probably not that high. But I mean, you have to get a lot of these parts machined and stuff, and so, cause like,
I mean, probably they just repurposed like a pressure thing. Like I could imagine that used on like milk farms,
they
something
use
like that.
what?
Like this pressure thing, a pressure tank could be used at milk farms.
Oh, really? Is it?
Yeah.
Hmm. I
I
mean,
could imagine this whole thing would cost you around 20K somewhere in China.
oh,
I mean, you could always reuse it.
you're talking about the big one.
Yeah.
Yeah, yeah. But I mean,
Obviously not a small one, because like what? It doesn't make any sense. How could you use it?
yeah.
It's just a toy.
Well, there are a number of applications. I mean, yeah.
Really? I
Uh,
mean, like
well,
I could see it shooting people, but I don't think that's legal. Uh,
yeah, yeah. It's super illegal especially if you put like a real firearm on it. That's a felony in America.
oh
Um,
shit.
but if you put a paintball on it, it's actually I don't think it's illegal. It's only illegal if it's a lethal firearm, and paintballs aren't considered lethal.
Oh, and
Um,
I could see it used like making it small, attaching it to a drone, and like shooting crowns on your farm.
Yeah, exactly. That's what I was thinking of and that is actually is pretty common. I was just watching a video on that yesterday. Is to keep birds and animals from eating your crop, you have like a automated scarecrow type of thing. Sometimes they shoot water though. They
Yeah,
don't shoot like pellets because then you have to kind of clean them up. But water is like fine.
you you could shoot beans, I guess.
Yeah,
Dried beans.
yeah, that's actually
I
hilarious.
mean, sorry. I meant to say not beans, but peas. Like
Mhm.
the green ones. Like
Yeah, yeah,
they're round.
because they're yeah spherical for sure. Yeah. So
Yeah.
okay, so this is like definitely.
Oh God, wait. I'm sorry. It just reminds me of the this game, Plants versus Zombies.
Oh
Right?
yeah,
There was a thing that was hidden.
Plants vs Zombies was that's such a good game. I haven't played it in probably 15 years, but on my iPad or my iPod Touch, I used to play that all the time.
Yeah, it was kind of fun game.
I wonder what those well, who made that? It was like PopCap or something. No,
What?
who made that game?
What is pop?
Oh yeah, it was PopCap. I wonder what else they made. Oh, they got bought by EA. Okay. Oh yeah, they made Bejeweled. That's right. They made Bejeweled. I don't know if you ever played that.
I don't think I have. I mean, probably I have, but I
Yeah,
just don't
right.
remember what it was.
No, Plants vs Zombies was definitely their best game. Okay. So yeah, I just want to look at this assembly for a second. So they have pretty similar to what I have, except let's see, do they show a better shot of this thing?
And he's going to paint a
No, it's a
picture
bit less
for
of
you guys
Roberto, right?
in the
It's a what?
I mean, Roberto, right? It's like a V 2.0 from Futurama. Have you
Uh,
seen it?
I've seen Futurama, but a long time ago. Oh
Yeah.
yeah, the
Oh,
stabbing guy.
no, wait. At Roberto 2.0, like version 2.0. Oh, he was in a corner, but yeah.
This guy. I don't remember this episode.
Yeah,
That's
yeah.
so funny.
It reminds me of your thing. Like,
Really?
everything just slapped on the top of it. Yeah, like
Okay,
those his eyes, right? You also have this similar thing, like
that's
two
so funny.
caps, two circles
What
on top of
episode
it.
was this in? I wanna find it because I feel like I saw the whole show. Wait.
I think that was an old one. Oh, I think that new episode's coming out.
Oh, really? They're still making Futurama? Oh, you know what? I think I heard about that.
They like, yeah, they like resurrected it like a year ago with I think most voice actors are actually original ones.
Oh, that's so good.
Yeah. But yeah, I just don't find it funny anymore. It's just I guess it's either me or just jokes just changed. I don't
Yeah,
know.
yeah. No, yeah, I understand what you're saying. Do you still find the old episodes funny though? Or is it just like in general it's not as
Some of
funny?
them are pretty funny, but yeah.
I haven't seen it in
I
I
would
I probably watched it in middle school, which was like yeah, like 15 years no, not 15, like 10, like 11 or 12 years ago. So my sense
yeah,
of
some
humor has changed a lot. But I still
yeah.
like Futurama. Like, uh, what are some good bits from it? I can't really remember. I always like the episode where they like where Bender becomes made of wood and he becomes like an anti-technologist.
Yeah. And there was a guy who they put insert like a audio cassettes inside of him to play sound.
Wait, I didn't catch that. Maybe I should get headphones.
Yeah, yeah, he would get on the island, right? And there was a guy that would insert like audio cassettes inside
Oh
of him to
yeah,
play a sound.
yeah, right. I forgot about that. What episode is that? Woodbender. I also there was like a couple movies that were on Netflix and I watched those.
Yeah,
Oh,
yeah.
absolutely fabulous. Season 4. Oh yeah, I forgot about the mom's friendly robot cup. Oh yeah, I love the anchovies episode where like the genome of anchovies have been completely decimated by Zoidberg. Do you know what I'm talking about?
I don't think I do. Probably I forgot about that. Let me just look it up. Futurama.
Yeah, oh yeah, and Fry becomes like the richest guy, but then he spends all his money.
Yeah, this one I remember.
I really like this episode. Well, let's see. This was yeah, this was season 1. Oh man, what a good show. The Simpsons is
Yeah,
also
I
very
think
good.
somehow. Yeah, sorry.
Go ahead.
Yeah, I think I somehow missed one about the anchovies. I don't remember.
Yeah. Let me just look at all the
Mm.
episodes. Oh yeah. Oh yeah.
Damn, it's old.
I know, 99.
Yeah.
Oh yeah, Zap Brannigan. Yeah. Okay. All right, that's enough Futurama. Um, okay, yeah, I want to look at this painting robot. This thing is insane.
The way that a CPU might do it, as a series of discrete actions performed
I
sequentially,
mean, the amazing thing is that this thing is on it's
one after
drivable.
the
It's
other.
not like on a
In
tripod.
3, 2, 1.
I mean, it could be like two parts, right?
Yeah, yeah, but
I mean,
uh,
I mean, I don't know. Probably just me. I just don't find it as fascinating as you do. Like, there are like already like toys you can buy to build something on top of it, and they're pretty cheap.
yeah, there's this
You know, like a tank looking things, like RC toys.
yeah, you know Mark Rober?
No.
Okay, he's just a big YouTuber, but he has this company and they made this, let's see, Century Turret Crunch Lab.
Okay. Okay.
They
I think I do know what you're talking about now.
yeah, yeah, he's
Of it
pretty,
through the side of
but
the
he
mounting
made,
piece
let's
and
see.
the opening of the
Yeah.
welcome
Yeah.
possession.
I've seen him.
Yeah, yeah. So yeah, so you can just buy this thing and it's basically what I'm building. The thing that for me is mainly the challenge of having to design and model everything myself. That's more why I find it interesting. It's just sort of like an arbitrary
Oh,
goal that you have to accomplish on your own.
got it.
But I mean,
Yeah, because I'd probably just steal design, like just
no, but
check how it works and like I'm
even
copying it.
stealing the design, there's still so much like this design is not
Yeah, no doubt.
like this is a lot of this is just stolen ideas of like how to put it all together. But then like you have to like get the parts and you have to like write the software. Um and then they look at this big slip ring. I actually don't know if they're using a slip ring. Maybe they're just it's just a bored hole. But you can't really tell everything that they're doing. And then I don't know what this yellow thing is on the front. And then they have to control the feed of the ball like they control every shot and I that's the part that I'm struggling with right now is like this hopper up here has a little motor in it that spins the balls into a channel. I mean, it's a lot easier. Well, they basically took apart a paintball gun and then they have the full assembly of a paintball gun. So that's maybe I should just use compressed air. Cuz right now I
Wait,
have
don't
like
you?
no, right now I have
How
like
does it?
two wheels. So like these wheels they spin in opposite directions really fast, and then the width of the ball is less than the width between these flywheels. And so then it compresses the ball a little bit, and then the friction force allows it to propel forward. So
Eh,
if you look at like a pitching machine, actually, does anyone even play baseball in Poland? Is that a big sport in Poland?
no.
Yeah, that's definitely does not sound like a big sport. But anyways, if you know what a here, I'll just look up pitching machine. So basically, it's a let's
Is
see.
it like a toy for dogs that like throws a ball to them? Or?
No, it's if you want to practice baseball, um, you
Yeah. So people usually use those for dogs here.
oh
They're
okay, yeah,
usually smaller.
yeah. But so anyways, this is like a
Like
flywheel
you just
system.
place it.
And then based on the different speeds of the three flywheels, you can add a spin to the ball. So, you know, when people actually pitch in baseball, they throw it with like a curve ball or a fastball. And so with different speeds on the motors, you can control that. The nice thing about
Is it accurate?
what?
I mean the thing, like how can you control where you want to shoot?
So this thing, yeah, you just have to point it. That's the thing that's annoying.
Okay, so you use like additional motors to move it horizontally and vertically, right, to aim it?
So yeah, so you don't move horizontally and vertically because then you would need a gantry system that runs on rails. Instead, what you do is you have
I mean, you tilt it. You tilt it. I
yeah, right,
understand.
exactly. You rotate this and then you rotate this. Unfortunately, um, I just did the joints wrong in this program and it doesn't work. But this one works. And so yeah, you just move it like
Yeah, I got it.
that.
What is this pink thing on a side? Is it the motor?
Yeah, so this is called a stepper motor. And
Stepper motor, what are you doing?
huh?
Stepper motor, what are you doing?
What do you mean?
What does it mean?
Oh, stepper motor. So
Yeah.
a stepper motor is let's see if we can find a cross section. Um, Essentially, a stepper motor is, I think, just like a normal motor, except it has way more poles or something. So you can very accurately control in
Okay,
steps.
got it.
So you know, in
Yeah,
normal DC motors, when you provide a current to it, you don't really have any idea of how far you've gone.
yeah,
But this, you can say, I want to
I
move
got it.
50 steps, or like, you know, and you can control that. The
Yeah.
thing that my stepper motors don't have, though, that's would be really useful, which something called a servo motor has. The problem is servo motors don't have well, a lot of cheap servo motors that you buy, they don't have full 360. They only turn like 180 degrees. But these have what's called closed loop feedback. So they have a little potentiometer in there that's basically allows them to know exactly how far they've gone. So the problem with a stepper motor is that if you try to have it control more torque than it can handle, the motor will stall. But the thing is, the program that you're running doesn't have any feedback that the motor stalled. So it will think that it's moved 250 steps when in actuality it didn't move at all because it was trying to move something too
Yeah,
heavy.
got it.
And so that's actually the problem that I had is that this small motor trying to move the whole weight of these motors and this whole assembly, it just stalls. So like right when it gets up to the part where it's like sort of heaviest, it just falls back down and it can't complete the aiming. So it can't stay upright, which is a big problem. Um,
So are you
so
going to replace the motor or
Yeah,
what?
so I have these new motors. I don't know if you're watching the Twitch stream, but these
Yeah, I
motors
do, I do.
okay, yeah. So these are called brushless motors, and I won't really get into the difference. The main thing is that they're lower friction and well, these are basically drone motors. So I have these and I tested out maybe 2 streams ago uh a flywheel and I actually got this cool sensor. We were talking about this a minute ago, called this magnetic sensor, and I was able to calculate that these are probably running at max throttle somewhere between 7 to 10,000 RPM, which you can then use to calculate uh you can use to calculate the what's called the tangential velocity. So basically how fast is this flywheel? Let me just do a quick join so that you can get a better picture of this. Okay. So this wheel is spinning at the end, and you want to know at this rim how fast is it moving, not in like radians per second, but meters per second. And so you basically just multiply the RPM, or basically the angular velocity by the diameter or the radius. And I was able to calculate that at, I think, 10,000 RPM, the tangential velocity for I made this smaller, but originally I had 80 millimeter diameter, that the output velocity of because this tangential velocity, if you assume that the ball does not slip, basically as the ball enters, there's no slippage going on. It's basically tracking and rolling along this thing. That the output velocity of the ball is equal to the tangential velocity of this wheel, and you get about 40 meters per second, which is not terrible. I have yet to do the experiment on the brushed DC motors, but I'm fairly certain that the brushed DC motors are faster. But they're so heavy that
Uh,
you know.
are those also stepper motors?
No, so these are called brushless DC motors, and these are called brushed DC motors. And
Wait, but then you don't know how many degrees rotated, no?
well, but the thing is, their purpose is just to go fast and spin. They don't need to move in a controlled manner, really. I
I
mean,
understand, but don't you need your motor to move in a controlled manner?
well, the main control that I would need is I need to control the RPM. I need to make sure that the speed of this flywheel is the same as the speed of this flywheel. Otherwise, I'll convey a spin on the ball, and I want it to go straight down. So, but I don't need to say to these motors, move 90 degrees or like something like that. I mainly just need to say, go this fast. Because,
Um,
yeah.
yeah, I honestly don't really understand why.
Okay, so let's.
Where would it be? Wait, now I understand. Were those like brushless motors be on top?
Yeah, so this assembly is going to go up on top here.
Oh, all right.
Yeah,
Because
so
I thought
I'm
at
just
first that
replacing these
you
ones.
wanted to. Yeah, got it. It's at first I thought that you were about to replace the one on the side,
Oh
the pink
yeah,
one with
no,
one.
no, I'm probably not going to do that, because if I want to aim at the corner or the center of the canvas, I need to know exactly how much to move.
Yeah, that's why. Yeah, that's why I asked you.
Yeah,
Because
yeah,
yeah,
okay,
got
yeah.
it.
No, yeah, that's a good question. And actually, these stepper motors are pretty much what every 3D printer uses to control its movement, because it's so hard to,
Yeah,
yeah.
makes sense.
Um,
Wait, but don't you have to replace it because it's stolen right now?
because it's too weak. Wait, what'd you
Yeah, I
say?
mean, you previously mentioned that it was stolen, right?
Yeah, so it's
And
stalling with
because it didn't
these.
have the yeah.
So these motors cause it to stall, but these motors are probably half as heavy. So I'm pretty sure that with the new assembly, I'll be able to lift.
All right, got it. So instead of replacing the motor, you just made the whole assembly lighter, right?
I mean, yeah, right, exactly. Because I have in my Amazon cart some bigger stepper motors, because they sell, basically every shape and size of stepper motor that you can imagine. Oh, and by the way, one extra thing is there's actually 2 stepper motors, right? Because one for each axis of rotation. So there's one on the bottom
Yeah.
to control this, and then there's one on the top.
Yeah. Yeah, makes sense.
Um, yeah, so I'm basically just in the process of designing this, and the first thing that I'm gonna do actually, because I mean, for me,
Oh, I have a stupid question.
yeah, what is it?
Wouldn't the whole assembly be lighter if you replace how motors are located? So, okay, so the tilting motor would be underneath the rotating motor.
Wait, let's just define some terms. So this direction is called pan or yaw, and then this direction is called pitch or tilt. So which one? So you're talking about the tilt?
Okay, so if the okay, so damn, how do I explain it? Uh, right. That is so hard. Um, yeah,
Yeah, I
if
know.
those bolts or if those connections had names like A, B, C,
Okay,
D.
wait. You
Okay,
can.
the thing that yeah.
Oh no, yeah, go ahead. Yeah, I was. Yeah, unfortunately, I designed this in a software that doesn't have a collaborative. Oh, actually, it does. I could invite you. I could. You could join this design if you wanted to, like, actually click on
But
it.
I would yeah, but I would need to download Autodesk Fusion.
Yeah, you're right. You're right. Yeah. See, that's why I need to switch to
Right.
Onshape because Onshape works in the browser, and then you could just join and click on things. But that's for
It's
another
okay.
time.
Okay. Let me just explain in the most layman terms I can, right?
Yeah.
Because that's what I am. Do you see this huge blue wheel, right?
Yeah.
It's lagging a bit for me. Yeah. So imagine if the middle of it was connected to your base instead.
The the center of it was connected to the base.
Yeah. So um, imagine that your base, right, would be this green thing that is standing on top of the how do I explain the color? This green bluish thing. That would be your base, right? Oh god, I
Okay,
think my
wait here. I'll
connection
just
died.
define the names of some of these parts so that I know exactly what you're talking about. So I call this thing the pink, the bottom plate. I call this the top plate, and then these are just gears. So you're saying mount this gear to the bottom plate?
Oh god. Okay, you know what? I have an idea. What if I just paint
Oh yeah,
instead?
yeah. Where's my Discord?
Let me just. I want to close stuff here. TL draw, right? Okay. You had it blue. Oh no, I wanted to make it more fat. I guess no. Can you see that?
Yeah, I can see it. Yeah,
Hey, awesome. So we have this thing that is like your base. Oh, was it pink? I think it was pink. No,
yeah. It was pink.
that's not you.
Oh yeah, you won't be able to see it because I'm watching your. Uh, I can go back to it
Yeah,
here.
can you just go back for a second? Yeah, can you just go back for a second? Oh yeah, it was pink. Oh, and the motor is inside of this base, right?
Yeah.
Yeah. So here's what I meant. So instead of the pink and the bottom, here we have the engine, right? And then this green, how do I call it? Like the
Yeah.
frame or whatever. And then you have the wheel here, right? And the motor somewhere, I guess, here.
Mm-hmm.
Makes sense, right? And then
Yeah.
you have this whole thing on top.
So the
Kind of
reason.
makes sense. So what I was asking is, what if you do it in reverse? So you have the base green, right?
Okay. Yeah.
Uh, then you have this thing here, kind of like that.
Yeah.
But then the thing that rotates the horizontally, right,
Mm-hmm.
would be here.
I see. Yeah, no, that's actually a very good question. Uh, I don't think there's any reason why I couldn't do that, and I haven't tried it, but that could be the right way to do it. Let me think about that. Yeah,
Just
so yeah.
Yes, what you avoid is that your green base thing that like holds to those axes is on the ground. It's not the part of the assembly
Yeah,
that is rotating.
right. Um
The only thing that worries me is how do you connect the horizontal axis to the like this bit right here? I'm not sure how it would work.
oh man, that's breaking my brain. The problem for me and the reason why I
Oh,
actually
it's breaking everything. Yeah.
well no, I mean it's this is why doing this project is so fun because I've never designed anything mechanical before, so it's like so hard for me to visualize, but it would be a good idea to try tilt and then yaw as opposed to yeah, first going this way and then going that way. Let me think. Um
I mean, your base would be much heavier, obviously,
yeah.
because
Well, what
your
I would
green
do is
thing,
I'd
right?
probably
This thing
mount
that
it.
is green, it
I'd mount it with bolts to something. But yeah, right. It needs to be very stable on the ground. I agree. Um Let me just like try to sketch something out on my paper. Okay, so you start off with this L bracket, and then you have this stepper motor, and this is just the ground. And then this rotates something in a bearing. And this is a gear, and this is a gear. And
because the thing that tilts, it also doesn't need to make a full circle because it doesn't make sense, right? It just tilts like, I don't know, like 30, 40 degrees. Yeah, how many you
yeah,
had there?
the tilt, yeah, maybe 70 at maximum, but yeah, it's definitely doesn't need to be um
Yeah, yeah. So you don't need the fancy thing with the with wires there. You only need it in the for the turning.
hold on, I'm trying to visualize this thing. It's so you have tilt. But now how do you get it what does it look like when you turn it side to side is the question. Okay, yeah, let's just say that there's like a big plate that has bars coming out of it, and those bars connect to the so yeah, one thing to say is that in here there are bearings which can allow it to rotate freely. So that's all I'm thinking about right now is these are the bearing things.
I mean, those wouldn't be that big because that would block the side. Then it would the big wheel, this blue wheel, would need to be small.
Wait, why?
Because imagine that. Could you please zoom out a bit?
Yeah, yeah.
Uh, because imagine that instead of the steel thing, is steel a proper way to explain the color? I hope. You
Teal,
have
yeah,
the
teal is
pink
yeah.
base. So when the spin base uh, rotates for the quarter of the circle, then your gun points to the this huge blue god, what was it? Gear, right?
Mhm.
And it just blocks the side of it.
Okay, I'm having
See
trouble.
that?
Give me a minute. I gotta think about this. So okay, so let's just say that we had instead of this whole thing, if we turn off, let's see, this. So instead of that, we have a gear here, and we have a big platform that can rotate, or that can rotate
Wait,
in the.
wait, I have an idea. I have an idea. Could you please add this thing back, and I will just add it in a paint or something.
Is it?
Uh,
Is it? Oh, it's this. Okay.
could you please zoom out a bit so the whole thing is easily
There we go.
visible? Also, let me just screenshot the whole thing. Then let me just go to teal draw. Oh God, it's so small here. Okay, here I'm like what? I'm screen sharing, I guess.
Yeah.
Check this out. I grab this thing. I have two of them now. They multiply. Look what I'm doing here.
Yeah.
I need to rotate it, obviously, because that will be our base. Boom.
Um.
Now, oh no, I cannot erase it like
Wait. Why did you flip it
you
upside down?
because the top now serves as a base. I mean, okay, I could also do this. Oops, it's the video. I mean, I could probably do this thing also.
Because you're saying make that attached to the bearing.
Yeah, now this thing in the bottom does not exist.
Yeah. Yeah. Right.
Because that's a base. So now the only thing that actually is affected by two motors, right, that needs to
Yeah. Yeah.
turn
Right. Is that top
is
part?
this thing.
Yeah.
Yeah, and you can directly mount it this on this base. Yeah. The okay, so this wheel, this gear needs
Yeah.
to be smaller because let's imagine that we have like a gun here, right?
Yeah.
And it like if it's pointing at us or from us, right, in the opposite side, like nothing really wrong with it. But when we rotate it and it starts pointing into the gear, it's like yeah, it blocks our
Well, so yeah,
vision.
that's actually something I ran into. And so I had to make this thing taller so that it didn't hit the gear. So as it stands, the current design, if this thing, well, okay, I see what you're saying. Yeah, yeah, yeah. Yeah, you just have to be aware of that. Mm-hmm. Yeah.
Yeah. So if you could make the gear say small, so it would fit on the side of the base, right? Or something like that,
Well, you would just,
or just make the gun on top of it, right? So we can like stick out.
yeah, because the thing is, the gear being that size is determines the mechanical advantage that you have. So,
Yeah, I understand. I understand.
okay, yeah. Um, so I'd have to see
Yeah,
if,
I mean, you could also make this small gear, then a big gear, and then small gear, but the small gear would have the I don't know the proper term, so it would have the same rotation as
yeah,
the
yeah,
big
right. It
one.
would move in the same
Uh,
direction. Yeah. Um, okay, that would probably to redesign everything would.
like I'm sorry, I'm talking about the gear that we don't affect it. Like there is a, I don't remember the proper term for the gear. So there's like a big gear, right?
Yeah.
And then you have a small gear that rotates with this gear, but it's like inside of it.
Oh yeah, yeah. That's
So
usually called like a planetary gear or like like the outer one would be called a ring gear, um, because the teeth are on the inside of it. Um,
yeah, because I've seen the thing that you could like connect those two things here, and this one would rotate with the same what
yeah,
do you
yeah.
call it, speed, whatever. So yeah, you could just displace this whole big wheel a bit lower then, because the thing would be somewhere, I don't know, somewhere on top of it.
Oh wait, are you saying that
I
this
don't know.
outer gear rotates? Okay, okay. Um,
Yeah, so you don't have to sacrifice the
right, the mechanical advantage. Yeah,
yeah,
yeah, because
and it would be lower. Like it would allow you to place it a bit lower because the actual thing that would move this base, this platform would be on top of this gear somewhere. I don't know. I'm not any good with it. Just my imagination. That's how
yeah,
I would
yeah.
probably
No,
try to do that.
honestly, Okay, I'm so deep into the current design, but I mean, at some point, I would love to try to do tilt and then pan as opposed to pan then tilt. But it takes so much.
Yeah.
I mean, it would take me probably like 10 hours to do this, just because even though I have all these designs, I would probably need to start from scratch.
Yeah, I understand.
I
Yeah,
mean,
that just would be my first idea because you're just trying to avoid this whole junk of stuff on top of it.
yeah.
It's like a lot of stuff going on.
No, yeah, I mean,
But
and the thing is, it's heavy. That's the main problem. It's very heavy.
yeah,
Let me look at
yeah.
how the
And,
Mythbusters did it. Did they do
oh,
pan?
they did it the same way you did, right? I think.
I think, yeah, so they pan and then they tilt.
Yeah, because it's definitely simpler.
This one is a lot simpler.
Yeah.
Did they? I want to see some more pictures of this thing because realistically, this
You
is
might do it as a series of
what I'm trying
discrete
to end
actions
up with.
performed sequentially, one after the other. In 3, 2,
Dude, I'm so glad you showed me this video. I cannot believe that I'd never seen this.
1. Let me speed it up.
Probably they had like a behind the scenes episode where they show how they build it. Or, I don't know.
Yeah, let's see.
There is a not 10 minutes video.
We're here, and there's a lot of confusion. All right,
Yeah, there is
this
actually 10
series,
minutes video. Let me
ends
send
with-
it to you.
Okay, you got it.
Oh, here we go. Yeah, and then we get a side view of it, kind of. Wait, oh, okay. Wait, they do a calibration step. Yeah, this is exactly what I wanted to see.
There we
Feel
go.
the tape
Okay,
off?
you got to
You did.
aim them a little bit to the right.
Okay.
Oh, wait. That's pretty. Are you guys ready? You want to see this?
Wait a second.
I
Is that
love
good
this
enough?
crowd.
Or should I go up?
Oh, yeah, you got to move forward. Sorry. That's our mark.
Okay.
Come on. No, you got to come on in.
Yeah, hold on.
But first, you got to come on in. Jeez. Come on. You're going to move forward. See, that's your mark. Okay. Okay, now you're going to move down and to the right. It's just like this on the show, so they edit it to make it faster. What do you think?
Let's see.
Here
we go.
Oh, that's it. Okay. Here we go. Army.
Hold on. Let me.
Oh wait.
Oh, God.
Oh, they didn't. It's too zoomed in. I wanted to see this front part. I really want to see that.
Yeah, let me just check. You know, it says it's in place, but I like to.
Okay.
I like to draw behind. Looks good to me.
Arming.
So you turn off the other one? Or
Yeah, no, I don't turn off the other one. I just go on that one. Okay. This is
You guys
CPU.
ready?
Remember,
You wanna see what it
CPU. In 3, 2, 1. Let me speed it up.
That thing is so badass. Wait, is that really how fast it goes? That's like more than 1 per second. That is really good. That is so freaking cool.
For demonstrating the GPU and the immense power it has to do parallel processing, to do high-quality graphics, we wanted to paint something more
Couldn't you
complex.
make
We
it
wondered
even
what to
faster
paint.
now?
Huh?
I mean, if that was the. I mean, if you really wanted to make it faster, you could, right?
Well, I don't know. But basically, right now, my goal is a 100 by 100 pixel image that I render. And that means that that's 10,000 shots that I need to fire, assuming 1 pixel per. So there's a lot of unknowns in how to actually accomplish this.
And we realized the answer was staring us in the face. We'd named him Leonardo. We'd painted a smiley face. What's the most famous smiley face in the world? The Mona Lisa. Exactly. There we are. There she is.
All the
So we
focus is
realized
going to be on the. Let's see if there's a cross section. There's no real good like image of this front assembly. I want to see if there's a This is probably just going to be about the difference between CPU and. Yeah, what a worthless. Okay, hold on. I'm gonna run to the restroom.
Yeah.
Oh, are you still there?
Mm-hmm.
All right,
Yep.
let me the reason why I noticed that you were off my Discord is I wanted to send you this thing.
Yeah.
Okay, wait. So I don't know. It's in my Twitter likes. Let me just find it on my phone. Basically, it was just this random thing about the Polish American vote apparently has been right on predicting the winner of the U.S. elections like 92% of the time. It's like so. Let me see.
Wait, what?
I think there's a chart in here. Oh yeah. Okay. All right.
Was there like a stat or a poll? Or how was it calculated?
I I honestly don't know, but this is the chart that I saw on Twitter. It's like um
Did you send me somewhere?
huh?
Oh wait, wait. I picture it. Never mind.
Do you
Um,
see it? Yeah. So this just shows like Polish Americans voted 74% for Woodrow Wilson and he won. Then Warren Harding, Calvin Coolidge, they won from 1916 to 52. This one was a really close one. And then Biden, Trump, Obama. I mean, all interesting. Oh, these are results for Polish Americans in the city of Chicago only. Okay, so that's kind of huge subset, but or a small subset, but that's pretty interesting.
Yeah. I mean, it's not that interesting in cases where you had like 90, 80, 70%, because
Yeah,
that's just
yeah,
that's like
right. Yeah.
uh, but when they were close, like say 55, 50 something, then yeah, it's interesting. Wait, what are those things at the right? Is it the opponent
Yeah,
percentage?
yeah, exactly. This is the other candidate and how much percentage they got.
Oh, I see now. Right, it was pretty big on like, what's that called? Third party, third
Huh?
candidate, or what? 54, 42.
Yeah,
So it was like, what, 4% for like other candidates?
yeah,
That's
exactly, yeah.
pretty.
But see, in this
Oh,
case,
look at that. 2012. It's big.
oh yeah, wow, that is big. I wonder who they went for. Who was the independent?
Yeah, 12%.
Oh yeah, wait, Gray? Oh, Gray was the VP. Yeah. I think it was Gary Johnson. Who is this? The Green Party? Jill Stein. That's right, Jill Stein. She's so funny.
I have no idea who all those people are.
Yeah, I mean, you got to be involved in. You got to like. I mean, I don't even care about politics, but I remember that election.
I mean, I know the big names here on the list,
Yeah, dude, this just
but
shows
not
my
all of
American
them.
ignorance. Do you guys vote? What's the deal? Do you guys have a president?
Yeah.
Okay. Wait, do you? But what is the like? Is it parliamentary or do you also have like a three house type of thing that we have, or a three?
Three house. Honestly, I have no idea what three house
No,
part
the
of
three
thing
house is not the
is.
right term. I meant three branch,
Like
where you
like
have an executive
yeah,
branch.
yeah, yeah, yeah. Yeah,
Do you?
but it's not really American thing, isn't it? Like more Latin thing or like Greek thing? I'm not sure where it's coming from, but it's old. It's like 1,000 years old.
Okay, yeah. Let me ask GPT. What's the
Well,
history of the
you asked
three?
like executive branch, right? It's
Yeah,
like
legislative and uh, uh legislative, executive, and then court. I forget what the.
yeah, yeah, yeah. I mean, it's old. Like
Okay, separation Montesquieu in the 18th century, but does it? Yeah, no. I think this thing is our thing, man. Judicial. That's what I was thinking of. Judicial. Does the
I
idea,
know. I mean, branches of government is old.
but like
And probably there's the
specifically
idea
the
of having three of them. Oh
yeah
yeah, yeah, maybe,
yeah. I
maybe.
think that specifically the separation of powers of having courts, executive power, and legislative power is the
Yeah,
American
yeah,
thing.
yeah,
But yeah,
yeah.
because no, because like in
Probably
the
true. But
UK they had
yeah,
the House of Commons and the House of Lords, so there was like and then the King, of course. So they did have two, I guess. The what is it called? The Parliament and
wait,
then the
but
King.
that's not exactly thing. That's not exactly the thing because you also have judges.
That is true. Yeah, there must have been judges.
Yeah, definitely. I mean, that's just yeah, that's just the first one. The I just ideal branch. Um, mm,
Oh yeah, the judicial branch is based on the British common law tradition, but the concept of judicial review, the power of courts to declare laws unconstitutional. Oh wow, it's only 1803. 20 years. 30 years after. That's very interesting. Okay, we have gone on a crazy tangent here. Um, okay, so anyways, going from this whole big thing to what I'm doing right now is a very small thing. I don't know if you're watching the video, but this is the part that I'm going to be modeling. I have this thing, which if you can see, it has slits down the edge of it,
Yeah.
and then you put on.
Oh, you know what I found? Hey, Aristotle. In his work Politics, Aristotle categorizes governments in three types.
Oh, really?
And he introduces the idea that different entities should balance different functions. Deliberation, execution, and how do I even pronounce it? Adjudication.
Oh, wow. Wait, okay. Yeah, Aristotle did discuss concept related to separation of
Though,
powers.
yeah, though he did not develop a distinct theory of separation of powers. So what was that thing?
That is pretty amazing. In Aristotle's Politics in the 4th century. Yeah, I mean, these ideas, that's the funny thing about studying history. And I don't study history as much as I feel like would be good for me. But like, these ideas are so old. It's just kind of amazing that literally, like, if you round 2,000 years ago, they were thinking about the same thing that we're working with today. It's just interesting.
It maybe not as intricate, but yeah.
Yeah, right. I mean, okay, so going back, so there's 4 parts that we need to model. The first part is this thing called the collet. And this basically goes on the shaft and then allows you to interface with the shaft. And this is something that's cool about, when you're writing code, you have to interface with other libraries. But when you're dealing with something mechanical, you have to interface with the shaft. And so the way that you do that, typically with a D shaft, so if I look at a D shaft, you can see that in a D shaft, oh wait, I have to
You still have a cam on the
yeah, I set a cam on
yeah.
my face. Yeah, so you have a cylinder and then you've cut out a slot onto it. And typically the way that you interface with this is you use a set screw. And so you put something around the shaft and then you basically have this thing go onto the flat and then you screw it on. And that's actually what I use in in here. So if you look at this 3D printed gear has a hub on it, and in there goes a nut and then a bolt. And so then that locks in place on the D shaft. But when I bought this motor, it came with this, which is a collet, which allows you to interface with a cylindrical shaft as opposed to a D shaft. So I'm modeling this right now. And then on top of it goes this piece, which I'll model. And that goes on top of here like that. Then you put in what you're, in the case of this actual part, you put in like a propeller, or in my case, the flywheel. And then on top of that goes this other washer. And then finally, a standard hex bolt, a hex nut. And so then you're locked in place. So the only reason I need to model this is I need to know the exact height of this thing so that I can build the feeder appropriately. Because this, just putting it on here and having it touch this is not the correct height, and I need the correct height. So we are going to model this. And so let me just, okay, so I have a plan. Let me just save this as collet assembly. And right now, maybe I should just call it the collet because I don't want to do too much at
Where
once.
I'm sorry. Where does it go?
It goes onto the top of this shaft. So you slide this on, and then when you tighten that hex nut, it clamps down these little slits, onto the shaft. So then it's really tight on there and there's a super high friction so that you're not going to slip, because you want to prevent this thing from slipping independently of the rotation of the shaft. So when you tighten this bolt, these things compress onto the shaft. So we just need to slide this thing on here, but the first thing we need to do is model it. So here's how I'm going to do it. I have my calipers, which is like the most handy freaking tool for doing this. And I'm going to just measure the diameter of the cylinder. Wait, hold on, I have to zoom.
What's the purpose of it again?
Of the collet?
Of this whole thing on top of the motor, on top of it.
Okay, well,
Like,
the thing
what
that
does it achieve?
okay, so what really attaches to this thing is this spinning disc, this flywheel. And this flywheel allows me to shoot the ball, basically, because the ball makes
Oh,
contact
right, because
with
it
this.
goes on top of it. Right.
Right, yeah. Okay, so this is like 7.7. It's probably a metric screw, but I honestly don't know. Okay, so let's just
So
do.
it needs to be properly fixed on top of. Oh, wow.
Okay, wait, and let me just get the height of this thing. So the other thing to note is that when you use one of these, it has what's called a depth gauge. So it has three measurement things. It has the outer diameter, the outer measurement, which you can use to measure, oops, something like this. Wait, something like, how do I get a good angle? Like that. But then you can measure the inside of something. So if I want to measure the inside of that, I can use this part and get the inside of that. Then I can also, if I want to measure the depth of something, I can go like this. Can you see? You can't really see it, but this is how you do it. And then I can get it to the right spot. So that's just how to
Does
get
it also display it on the thing?
Yeah, it displays it here. Can't really see it.
Yeah, because I don't really get the depth. How does it understand where you like
Well,
touch the end?
well, this thing is connected to this. So as this piece rolls, I actually don't really know how a caliper works.
Yeah.
I mean, that's a good point. But if you can see here, there's a rail on the back, and this rail connects to the depth gauge. So then as this gets pushed out.
Yeah, I don't really get the depth because. Oh, sorry, it's just lagging a bit.
Okay, yeah. Okay, so that's 7.
Yeah, I just didn't get the depth because it just looked like it didn't touch the. Oh, what's that sound?
Okay. Well, let's see. What is the total? 32. Because the total thing is 32. Okay, I'm trying to figure this out. Okay, so should we just extrude this by 32? I don't think so. I think what I want to do is extrude it by the distance to the. Which I'm just going to make an estimate. It doesn't really have to be perfect. All right, so I'm going to say that's 27. So we're going to extrude this by 27. Okay, then that means that this thing up on top of there is going to be 5 more. So, so the first thing we're going to do is we are going to create a thread, and we're going to see how far the thread part goes with the depth gauge. Or actually, we could just use this. 17, so then this should be 10. Okay, so we're going to say that this does not go full length, but instead it goes 17. and then M8, but it's probably M8 by 1. So that, and by 1 means that the distance from one peak to the next is 1 millimeter, I think. And then we don't need to model a taper or anything, so that's good. Then the next thing we need to do is figure out well, okay, let's do this. So we are going to create an offset plane from this face by 5 millimeters. Then we're going to draw a sketch onto here, and this is going to be the OD. The OD, let's see, the outer diameter is going to be, it's hard to get it right. 11. Yeah, let's say 11. Okay, now I've never done this before, but I think what you want to do is you want to finish the sketch and then you want to do a loft. And you want to loft this to there. And then say okay. Then on here, you want to draw a sketch and we're going to hole out, let's see, what is the inner diameter here? So let's 0 it again. It's 5. Yeah, and you know, we can check that because and you know what's so cool about modeling is that people have modeled pretty much everything online. So I didn't model this whole motor. This is way too advanced for something like me. I cannot, dude, like the amount of curves in here and then these blades and then this magnets and stuff, like this is a very hard thing to model. And then the cables, I did not do that. I downloaded that. So in here we're gonna make a 5
Is it an
millimeter.
exact model of the motor you use?
It's yeah, it is. It is. It's the exact model that I have. Flash Hobby D3536. Okay, so now we need to know the depth of how deep this shaft goes. So we can use the depth. This is probably a better thing to show the depth. So I have in there's a hole. And then I'm gonna put this, which extends down. Yeah, 0 it again. 0. Okay, then I'm just gonna go until it hits the bottom. And it says 14. So we're gonna now extrude this down minus 14. So now we have the hole in there. And then the last thing that we have to do is the slits. And the slits, I believe I can do this. I can draw on this face. And then how thick are they? This is gonna be since they're so thin, it's gonna be hard to, I don't know. They're probably like, yeah, sure. Let's just say 0.4 millimeters. So what
Yo,
we're gonna do is we're gonna draw.
I gotta go.
Oh, you gotta
It's
go.
time for me to sleep.
Yeah, no, you're good, dude. It's fun chatting, and I will
Yeah,
think about that.
it's not like it's too late. It's just that, yeah.
Yeah, for sure. All right, peace out, man.
Yeah, I just have some plans tomorrow. Yeah,
Yeah.
see ya.
See ya.
Bye.
My boy Olala, man, the freaking OG. Okay, so what do we have to do? Is we have to, because if I draw it from, oh wait, okay, wait. How do I want to do this? If I make a construction line, oh wait, LX. If I make a construction line from here to here, and then I make a rectangle here to here. Oh wait. Okay, this is 0.4. And then what is locked in? Okay, so that point is coincident. Then we want this and this to be midpoint. Yeah, right. I hate midpoint because, oh wait, you know what we can do? There's this. We can delete this coincident constraint. We can say that this and this are like that. And then that this and this are midpoint. Damn it. Hold on. So we move this in. I believe I can do this though, right? Okay, cool. So now we select this and this little sliver here. And there is a little sliver there, so we actually can't. It's probably that one. Let's make another line. Because I want it to be exact for no reason at all. I could just make it unconstrained, but I kind of want to say that this and this point are like that. Okay, so now we can select and extrude down. And I forgot what I said the amount is. We're gonna, oh wait. We want to do this and this, extrude it. And let me measure. Eight. Okay, then we are going to do a circular pattern of a feature, which is this extrusion, and the axis is going to be, can I select that? And then there's 4 of them. Awesome. Dude, that's sick. We have a collet. So now, wait, where did I save that to? Okay. Now it's the washer. So this one should be easy. It's just going to be, okay, 17. Twelve and a half. Or wait. First we need to, oh, actually, wait, hold on. This is kind of interesting because this thing is tapered. Its inner diameter at the top is not the same as the inner diameter at the bottom. So we need to do a lofted hole. So this is 8 at the, it's 8 and then it's like 10 and a half. So at the part where it's, this is only 8. Oh wait, so let's instead of doing this, we're just gonna extrude this by the 3.3. Okay, then we are going to 12 and a half, that's right. So now on here, 12.5. And then the height of that 5.2. The height of this whole thing is 8. $3.3. 8 minus 3.3. Wait, what? This whole thing is 8. And this is 3.3. Then that has to be 4.7. I don't know how I messed that up. Oh yeah, it's 4.7. Okay, now we draw a circle on here that is 10.5. Then we finish the sketch and we draw a circle on here that's 8. Now we take these two, we finish the sketch, we take these two profiles and we do a loft. Nice. I'm not going to do the ridges down here, but, you know. Oh, shit. Damn it. Dude, come on, bro. Why am I so cringe? Should I start over? Should I do it again? I'll do it again. Damn, that's so annoying. Okay. Or I'll just do the playthrough. Okay. Make a circle, extrude it, loft, hole, circular pattern. It's not that complicated. Okay, now this part, also not that complicated. Circle, extrude, hole, circle, circle, loft. Very simple. Okay, now let's do the top washer. Okay. Yeah, 17. Wait, was it 8 or 10? It was 8. Oh, can I fill it? Restart this to I don't know how you do this. Oh wait, it's a chamfer actually. goes down to like 2.1. Wait, what is the distance from there to there? It's gonna be 17 minus 12.5 or something. Wait, but then okay, if we say okay, then the distance from here to here is, oh, perfect. We did it. No, wait, we did not do it. Oh, wait, this needs to be over 2. There we go. Now we did it. Okay. Okay. So this is going to be the collet top washer, which is actually missing on the second motor that I bought, which is really annoying. And then I don't even know, should I even model the hex nut? I feel like I don't even need to do that. Okay. I might just not do the fillet at the end. I might just, because a hex nut is real easy to model. You know what? Let's just do it. It's so easy. Oh wait, I forgot to get my Amazon packages. It's getting to be that time of year where you got to put on socks and shit. And I bought another one of these for my desktop. But actually, I kind of want to go set it up. It just got delivered. Okay, it did not. It did not get delivered. Other stuff got delivered. So I got a bunch of screws. Self-tapping screws, basically. M series self-tapping. And more magnetic encoders. Because I broke 2 of them and I want some on reserve. Just in case I break more. Okay. All right, let's keep modeling. Okay. Yeah, the flats distance is 14. And then this is horizontal. And then the circle should be 8. Wait. Oh. Then we can extrude this by 6. Okay. Awesome. Okay. So this is the collet hex nut. So now the collet assembly. Nope. I'm going to upload this. Wait, can I just upload them all separately? Well, let's try to assemble it. I wish I could select multiple, but whatever. Ah. Okay. Why can't I right click this? There we go. I don't know, like 0.3. Oh, wait. Oh, wait. Let's redo this. Edit this joint. It comes down until... Wait. That's weird. Why is it off center? Why is it off center? What the freak? I'm just gonna upload it how it is. What the fuck? What the hell is this nonsense? Okay, so let's just yeah, this is good. Fantastic. Okay. It's so weird that it's off center though. I don't get why it's off center. That literally doesn't make any sense to me though. Oh my god. I'm a silly goose. I should have seen it there. That's so silly. Let's just do -1. Wait, but is that no? But it does. It's definitely not -1. Oops. Oh wait. Did I fuck this up? Did, oh my god. I have to post a revision now. Am I the dumbest son of a bitch alive? This is 1050. Oh yeah, no, that's right. So then what the hell am I doing? Oh no, okay. I'm just tripping, dude. It's still off center. Is that just because I didn't press OK? Okay, but this thing, oh yeah, so this thing does not go, it's like, yeah, it's like way less than that. This is 1050, and this is, and this is, and that's basically what it is. Let's do 0.2. Okay, that seems like pretty accurate. Oh wait. Can we can we fix this? I want to update this. So how do you do it? You like okay, wait. Let's can we project this? Oh wait. Bro, how do I get this triangle? Oh wait, we need a You can't mirror profiles. You have to mirror. Wait, what the? Is there not a line there? Oh, there we go. Oh, you have to do it from there. How do you do that? Construct plane at angle. Plane through two edges. This and this. Mm. Oh, wait, you have to do. Ah, mirror it across this. Okay, now we can select these two. We can finish the sketch. Profile. Profile S revolve. There we go. Now that's more like it. Oh, where's the hex nut? Oh, wait, did I? Let me just delete this. This is fine. Leave it as is. Can you add to an existing GrabCAD? Dude, it's insane that the GrabCAD's website is just that nonsense. Okay, so let's re-export the hex nut to step and then add the assembly. Pictures, 3D, ball shooter, flywheel encoder. Bro, where's the view button? View. You can't. Details. Nice. But I think I'm gonna redo the assembly. Let's do this over again. Wait, that's not the right center. Oh. I hate that you have to press this every freaking time. It's so ridiculous. Wait, is that the right? Yeah. So I'm just gonna start over. Oh wait. Is it better to fix that to change the joint? Let's do that. So instead of this, we want oh shit. Oh shit. Cancel. Oh, why do I keep doing that, bro? I'm so silly. Yeah. Oh my god, I did it again. Why am I doing it again? Oh my god, what is wrong with me? Okay. I'm not gonna press J. I'm not gonna press J. There we go. That's correct. Okay. All right. We're good. Oh wait, but we gotta get the all right. Looking pretty slick, if I might say so myself. Whoa, Mark Rober's on Hinge? What the fuck, bro? What the hell? Dude, that's so crazy. Mark Rober's on Hinge. Dude, what the hell? Why doesn't he have a smoking hot wife that's just like hella cool? What the fuck? I can't believe he got divorced, dude. That's insane, man. That's so fucking funny, man. What kind of tweet is that to open your what the hell, bro? Okay, all right. So this is that. Should we just okay, wait. So this is going to be BLDC pan only shooter. Okay. 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 So what I'm gonna do, I think is I'm gonna wait. Can we just open them up? Wait. This is not. Okay, so let's just insert top plate then. Yeah, let's just insert top plate. Where is top plate? Can we find that file? Was this just made directly on here? Okay, so let's just do an insert derive then. Um, I'm pretty sure that this just goes to here, right? What is this weird do we have the motion link in here? Right. Wait a minute. Wait a minute. What the hell? I am confused. Okay. Let me just open up that oh, but we were gonna do this whole thing of making it taller and stuff like that or something. I don't remember. But so wait, so this gear is just freely moving. This should technically be part of a top plate assembly though. And then the motion link comes later. Okay, I'm fine with that. So then let's don't save. So this wait, hold on. Can I turn off this fucking okay. So what is this? We need to I forgot how you do this. I always forget the motion links. So I'm pretty sure what you do is you join this thing to here, flip it, then do this, click on that. Oh, wait. Oh, wait, can we cancel this? I'm going to join this to here, flip it, and move this up to here. Okay. But we want it to make it revolute. Okay, but now this is locked in place, but it turns. And then where's my top plate? Perfect. All right. So now we need to save this. And we're going to insert another component, which is panel shooter. Can you do this? I'm curious. Circular reference. That would be so funny. Dude, that'd be so funny. It just like crashes. Oh man. Wait, what did I just do? Gemini rising. How big is your brain? Anybody honest? Oh,
Sunshine or rain. Tell me how big is your brain? I'll show you where mine is. I need to know how open your mind is. Pain. How do you feel about timing? Have you met another sign with the Gemini rising? Contradiction, love addiction. I can listen to anybody honest. Do you prefer sunshine or rain? Tell me how big is your brain?
okay. Um. Wait. Wait. Um. Oh. I'm just silly. No. This one also. Okay. There we go. Wait, can I play that again? Okay. So see how it's off center? It's off center because with the pitch assembly, you need space asymmetrically for the gear. But it's fine. So now we just want to build a new part that goes onto here. I'm trying to figure out which way the cable should be. Maybe I want to rotate this 180 degrees. Okay, wait, let's just freaking build this thing. This is bothering me so much that I can't just sit down and build this. Okay, so what does it need to look like? It needs to look like uh Let's just start drawing stupid stuff. Okay, as fast as possible. Just make this. Okay, or no. Let's make it. Okay, extrude this by I don't know 50. Okay, so now. Yeah, 13 maybe. What the hell? Wait. Why didn't that apply first off? But we need a wall. So let's extrude this to here and then make that instead -70. Okay, so a little channel. And then on here, basically we're going to have like can we just can't copy and paste sketch elements like that or profiles? We want it to be I think 40. And then you take these and then you rest the servo on there. So we actually want to change this to be like 80. We probably want to change this, oops, not that, but the extrusion of that to be and then the is this the right one? I think this is updated. Okay. So now oh, I messed this up again. Okay, well, we're not doing anything real. This is all just what? Oh my god. Okay, wait. We're gonna open this thing up. We're gonna finally fix this thing. First off, rigid group it. Save. Let's see if this moves them. Nice. All right. Baba dee boo baba dee ba boo ba boo ba dee ba boo. Now we just need to determine the height of this thing, and we also need to put the horn on. Do we have the horns? Where are they? I don't even know where they are. Okay. I actually really like this design. One thing we have to do is this sketch, I believe. The distance between here and here needs to be 40. Actually, and I want it to be yeah. I want it to be there's a tiny bit of clearance. Okay, so let's find the horn. I feel like I Oh wait, I think it might have been in this. Maybe they don't have the the thing that I want. Let's just 7.5. Wait, what? Oh yeah. This face to 9.8. Okay. Turn this back on, edit this sketch. Wait, what? What? Okay. Oh. That's pretty nice. This probably, let's make this, you can't put in 0. That's so weird that it doesn't just automatically convert it to like a coincident thing. $50 might be right. It doesn't tell me the distance. This point to this. 30. So you need a... And then mounting it is going to be a challenge. This is going to be a feeder, one shot. Let's just insert it in here so I can start to look at it. First thing's obvious. It needs to be way taller. Excuse me. The cables are going to be annoying as hell, but dude, I can't believe the Mythbusters did my thing like 15 years ago. It's okay. But that's insane that they built that GPU thing. That thing is so rad. How big is your brain? We could do a self-tapping thing, but we don't have My self-tapping caps out at M2. Okay, but let's just no. No. Wait, what? 10:08. Oh, so that's going to be a challenge too, is wait, why did it go? Oh, because of how I did the. This might work. Okay, well, that's not going to work. Contradiction, love addiction. So what are we going to do about this? Maybe we can move it back like 5 millimeters. Okay, okay, there's a number of things. The first thing, wait, let's save. Okay, the first thing is this extrusion needs to be 90. Save it. Update. Okay, then this needs to be 5. Okay, that's incredibly close, but it's not touching it. Okay, the big unknown is how do we fasten this thing to the ground? I think this will work though. Okay, so we just need to figure out how to fasten it, design this, or measure the servo horn, and then do a rudimentary design of it. Then, like, make the revolute joint so we can look overhead and see how it sweeps it, because it needs to get back to that point. 50. Maybe that's good. Okay, so and realistically, this can I hide it? Where is it? The holes are there. The holes are right. Okay. The holes are centered along that axis, but that axis in this case is not the center of rotation. Yeah, we have a midplane here. That's nice. Wait, is that a midplane? Yeah, that's got to be a midplane. Between this face and this face or something. Um, the thing is, they're kind of close. Okay, so let's do a new one. And this time what we're going to do is we're going to insert derive. Oh wait, no, it's not yaw. It's pitch. This template. Maybe I should just design it straight onto the thing. Okay. It needs Okay, so I think that instead I'm going to disable this. Okay, so how do we want this thing to look? I kind of want to design it as one part, but I could see how I could do it maybe with two. Okay, let's start with this. And again, we're just going to do a sketch. Wait, actually, okay. This is the center line. So let's make a line here. Dude, it's so annoying that yeah, I don't get how you have to do this. Okay, this drags it in. What did I say, 70? Okay, but then we want to do a like okay, first off, let's um oh, but you need the walls. Okay. So let's do this. Does it include that? That was such a roundabout, cringe way to do this. Don't understand that. Oh, shit. Oh, wait, but what is the diameter here? 10? That's not going to work. Oh, you know what? This and this don't get extruded. Oh, wait, but we want to actually... First thing, it definitely doesn't need to go that far back. It's kind of unfortunate because what is the distance? Is 30. Yeah, it's kind of exactly on top of where we want to be. Okay, well, let's just keep going because, like, I can't... Okay, so now we have a... Is it this? 20. See, that's too big. I wonder if we could put it... Nah, yeah, that complicates things a lot. Also, this is... Oh, this is off-center, bro. The off-centeredness is going to be really annoying, actually, because Because we need this to be over. This plane. Where's the other plane? Eight. So we need to take this and move this. Oh, wait. We need to move this by 8. It's not joined, right? I guess it is joined. I don't think by a joint, but by geometry. See, there's that, but now... Okay, well, if we make... Okay, let's look at the sketch again. I feel like this is totally bonked up. Yeah, with the move after, that's so gonko. That's so blizzy, bruh. It's so gonked up. Because, okay, so what we need is not this center line. We need to draw a line here, down, make this a construction line. Then we need to make the distance between here and here measured to be 8. Okay, now this is our center line. So going back to, that's the annoying thing is that you don't have, I don't know, can you click on the mirror? Yeah, that's the problem is you don't have parametric sketches really. It's all just in this sketch, but all these mirrors are, oh, whatever. Oh, wait. This needs to be, okay. Okay, so I feel like I'm ready to start this over. So what we're going to do is we're going to just undo literally everything about this. Okay. So the first thing we're going to do is we're going to make a line. Under here. We're going to make it horizontal. Then we're going to make the distance from here to here. Wait, what the hell? 8. Okay, we're going to make this a construction line. And now, let's just start on this side. So if we draw a rectangle, this is going to be both, and then we're going to add a line. I don't know. I'm picking random numbers. Oh wait, no, we need this to be like 20 because we need a line. No, wait. So this is 15. That's kind of high actually. But whatever. So okay, so we extrude this by 5. Oh wait, we need to project this. Dude, what the flip? Wait, how did we get that to be so? Wait, these are not. What? $25? That's actually kind of perfect. That's so goofy, bruh. That's so goofy. Whatever. We just want something that works. You can always improve on it, but like, just getting something that works is so hard. We're gonna draw a sketch on this face. We're gonna project this. That's so freaking stupid, bro. What the hell? I'm also gonna just do some random shit here. Just so I can get my damn finger in there. Is making this one part the stupidest thing ever? Maybe I can print it from here. Wait, did I make it 30 here or did I make it 25? I made it 26. So that's actually really good. That's pretty close to what I had. But excuse me. So can we hide this thing? Whatever. So on here we're gonna make a sketch and we're gonna project this and we're gonna project this. Now we're gonna make a center. And we are going to also do another one, I guess. We could, because we could do this. Oh, yeah, so that's stupid. We could do, why don't we do this? Ugh. Take this and extrude this to there. Now we're ready for, oh wait, now we should just put it on this side. Not even that crazy. How long is this? I feel like this is shorter than the other one. 58, 70, right? 80. And we even have a little backstop here for the wall. Oh wait, why is my gain so low? Yo, yo, yo. I think it's using the wrong microphone. It's probably the, hello? It's probably something. Oh wait, that was it. Hello? 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 No, wait, why is this so low? Hello? 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 It's like way lower than it normally is. I mean, it's never at max. Am I just normally talking way louder? I feel like this is weird. Anyways, let's just get on with it. Wait, 58? Do we even have enough room? Yeah, we should. Okay, so let's do it again. This could be coincident with that. Oh, wait. Should be 40, right? Okay, so first thing. Oh, So let's undo this extrusion and just keep editing this. Wait. Is that equal? No, it's vertical. Oh. Wait, what? This and this oh wait, not parallel. Okay. What is constraining that? That's weird. Okay, I'm just gonna undo all of this. I don't like the copy and paste of sketch geometry. Oh shit. Okay, I'm just gonna delete it. Yeah, no, not. Okay. Chasing you. Ah! Oh my god. Okay. Oops. Oh, we can delete this. And then I'm pretty sure. Wait. Oh wait, can we just cancel this? Wait, what? That seems fine. Wait, can we do both at once? That should. Wait, what happened? What the hell, bro? Oh, did we have the wrong? Oh. Of course it's the wrong thing. Why wouldn't it be? Wait, where are we? We're sketching on here. Okay. Where the hell am I? Okay, the question is now. From this point to this edge, 56. That's pretty close to what we had. The problem is, I'm worried that. Well, we should print this and just see what's up. But I'm a little worried that it's gonna make contact asymmetrically. Like, I think that this servo probably needs to be out a little bit more and then have a longer arm. But we should print this thing. Oof. Oof, oof, oof. Once you thought I was the president. Ooh. Yow. We'll definitely have to make, well, we'll definitely have to make these 4 metal. For sure. Even then, I think that this whole thing basically instantly is going to destroy this nut. Make it fall off, rather. And then this thing is going to go flying. But we are going to have to try it out, because otherwise, we got nothing. What a weird component. This is one of the weirder components that I've made. It's also not even symmetrical. How did I get that even wrong? Oh. Where can we go to this component and do a playthrough? So with this copy and move is what I want to look at. Hello? You can't edit that? We can edit the move. So what do we need to do exactly? We need to... Maybe it's fine. Doesn't matter that it's not in the center. Okay, I think we should probably... Can I just make a rectangle? Let's just make a... Nice. Fantastic. Fantastic. Oh, wait. Oh, God, what did I do? Okay, wait, now we gotta redo this joint. And where should the joint go? Man, you gotta be so deliberate. You really have to be, this has to go here. This has to go there. So, what happened? First, let's capture position. Now, I thought this... Oh, wait, but we want to edit this joint to be... What? Dude, what? Oh my fucking God. Ah! I'm pissed off, bro. Okay, can we... Wait, where did I even put it? Oh, is that why you have to activate this thing? And then I can do... No. No, obviously that's not how it works. Why would you think that's how that works? Okay, so it's clearly got to be longer. So if we activate horn, look at the sketch. I'm going to make this 40. Make this 6.5. We're going to project the thing that's not an arc. Wait. Oh, I just love that so much. Why can't I just drag this thing? Why do I have to go here? Animate joint relationships. I still think it's slightly too... Okay, and then now we need to activate this, and this initial extrusion, not this one, the second one. We're going to make this minus 10. Now we're going to activate the horn again. We are going to animate the... We should probably give a little bit more... Well, it's on the top, so this is actually going to be a little bit higher. And let's see, does this collide with that? No. So we're totally... I feel like we've got it. I feel like we can print this. I really just want to shoot something with... out of the... I really just want to get a real working thing down. All right. Boy, oh boy. Are we ready, dude? I'm scared, but let's just send it. Because otherwise, I'm just going to sit here all day. So we're going to print out this part, and we're just going to see what the supports look like. Do I need to reprint anything? I actually don't know. I think that this I have, and then these flywheels I have. So, and then the horn I'm not going to print. The horn I am going to print. I'm going to print this horn because... And it's going to be screwed in. Oh, interesting. So we need to actually find... I think it's this one. 90S. I think it's this. This is going to give me the min distance, though. Only 15. I don't even know if that's right. I'm going to go get one and then measure it on the calipers. But if so, we still need to project in those set screw things.
I thought that there was like a one-sided one. Let me go look upstairs. I feel like there is, where it's like, yeah, basically what's on the screen. It's not in this bag though. Okay, so it turns out that I don't have. I found the servos, but it turns out that I don't have that one. I only have. This. So what we're gonna do. Where is it? Okay, what we're gonna do is I'm just gonna turn this off, and I'm gonna insert. Oh wait, actually it's not that. It's gonna be this. Okay. Now, turn the horn on. And we want to remove its joints. So, wait, can we just edit the joint? Is it this joint? Yeah, sweet. So not between the shaft, but between, oh, can we, oh wait, okay, wait, hold on. Can we move this up? I don't know why I can't, oh, you know what? Wait. Okay, wait. So screw's gonna go in there. I want to make this, it doesn't really need to move all that much mass. I guess it's gonna go in there. Okay, now we need to rotate this so these are exactly aligned. Is it exact? It looks pretty exact actually. So that means that on this face, we're going to create a sketch. We're going to hide the horn and we are going to project. I said hide the horn. Bro, alright, whatever. And project this. Okay, now we're going to take these and just extrude them down. So the thing is, this is actually going to be higher than we sort of 7, but then the distance between, but then the radius of this is 25. So that's 22. That's going to hit the very top of this thing. That's not. That's not good. So we need to, yeah, on this face, we need to create a sketch. We need to turn off this and this. Wait, where did the holes go? Oh. What is this, top plate? The hell is this? Oh my god. The problem is I need to fix my scripts because my scripts don't deal with nesting properly. What am I still clicking on? What? What the hell, bro? We don't need to do all that. Oh, damn it. La 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 la. I'm so mad. Why did I do that? We can do this. That sketch, we can just delete this sketch, right? Activate the horn. Draw a sketch on the bottom face. Draw a line. Oh shit. Why does it always move me to the origin? $2.75. Okay. There's still a gap, so we're good. Okay, I think I'm ready. Hmm. Okay. Oh. I think that's it. Wait, can we? That should be fine. An hour and a half? That's not bad. That's the worst that can happen. I am gonna go watch it probably, or at least have the video on, because I'm still not like super confident that I'm gonna get no issues. Oh, did we trying to imagine the ball? Maybe a little bit shorter would have been better. The thing is, I moved my printer into the garage, and I don't know if it doesn't really get that good a Wi-Fi signal. Another big unknown is I totally lost my train of thought. I'm not sure. Oh yeah, is mounting the bottom plate to something, because right now there's nothing that holds that down. And then this nut is definitely gonna fall off. Oh shit, see that? Let's keep it playing. Is it still stuck on there? I'm gonna go run over there. Okay, I'm pretty sure I know what's happening. There's residue on the hot end. When it gets hot, it becomes sticky, and then it makes it very hard for the little poops that it makes to, and then the bed leveling is off. Everything goes downhill from there. So I don't think it's clogged. I think it's just getting stuck. Oh, wow. Wow, there's little... Dude, the A1 in some ways is like way better than the P1. The touchscreen and everything. Oh, I should take that off. Ugh, I don't want to do this. Okay. I want something from specifically for the P1. Okay, I think I know how to do it, but we need to wait for it to cool, right? Wait, let's try to reconnect. Um... Okay. Ugh. Okay. All right. So, long time with no update, but basically, this is what's going on. I took apart the hot end. Oh wait, why am I loud now? Yeah. Okay, so I have a p1s. I took off the magnetic cover and unplugged it. Then I took off the pin connectors, and I was able to take out the hot. I was almost able to take out the hot end, but I forgot to unload the filament first. So now I turned it on, and then that has to heat up the hot end. So then I have to what? Okay, and then now I have to wait for it to cool down before I can take it apart again. So we're just chilling for a few minutes. And we should be able to monitor it from here. This is totally whacked out though. I'm gonna reopen Bam. Oh, there we go. It's already at 138. Okay. Okay, so a little update. So you can see here, this is a hot end. It's gummed up on the top with a whole bunch of filament. It doesn't really want to break off. You really got to get it hot. And then the other problem is there's a piece of filament that's broken off in there. Similarly, I don't think that there'd be any good way to pull that out of there. Without it first getting really hot. I could try extruding a bunch, but I'm sort of tempted to just put in my my 0.2. Okay, I feel like I'm determined to fix this one. Can you just wiggle this thing off of here? This rubber part? I'm gonna look up hot end disassembly.
have our first clog. Luckily, I just got to remove these 2 bolts to get the hot end off. Once you get those 2 bolts off, you just grab it right down here and pull it straight down. There we go. So according to Bambu, I need to take an Allen wrench, heat it up, stick it in the open end of the hot end, let it cool down, then pull it out like a cold pull. This is gonna be interesting. That should be good. Ready, let's get, oh, there it is. Okay, we got it. Oh wow, that's okay. Come on. Hold on, put the camera down. It works. And yeah, I got something at the end of it. Looks like a piece of material stayed in the hot end too long and got degraded and hardened up too much. Huh, that was a lot easier than I thought. This is a perfect time for me to use some of my purge filament from Filaments Canada. Not sponsored, by the way. If you don't know what purge filament is, it's basically a cleaning filament. It's specially designed to stick really well to other filaments and basically push it out of the nozzle. Let's put that purge filament to work. Well, at least I know my nozzle is squeaky clean now. That is disgusting. And we've cleaned up the nozzle. Let's go ahead and put this guy back together. So now that we cleaned the clog, let me say this. I was dreading having a clog because I didn't know how involved it would be to actually clear it with this spring. Turns out I was worried for nothing because the front comes off so easily with magnets and the entire hot end assembly itself comes off with just 2 bolts. So it took me less than, what, probably 3 minutes to basically disassemble the entire hot end and have it in my hand. It's incredible.
Yeah, it is pretty great.
Products like this because maintenance is a required thing. And being able to do quick maintenance is a huge plus in my book.
Yeah, for real.
So I have a nozzle here from my X1 Carbon. It's the same nozzle across the X series and the P series. And like you can see on this label here, I got some TPU stuck.
Oh, perfect. This is exactly what I'm looking for.
Go through, and you can see it at the top there. And there's really nothing you can do about trying to pull it out. Like you can't get tweezers in there. There's no way you're going to get a grip on it. And so following the Bambu Labs guidelines, we're going to heat a 1.5 millimeter hex key using a lighter. And we're just going to light.
Hell yeah, dude.
Heat up the end here for 10 to 15 seconds. And I'm using the worst set of Allen keys I have. I'm not using my fancy ones. Get that hot, and then we're just inserting it. Into there. Next thing we're going to do is we're going to heat this end. We've taken the sock off already, and now we can heat the nozzle to try and pull this out at the same time and pull all that filament out of the hot end.
How do you take the sock off? What the hell? Wow.
There we go. It's hard to capture on camera, but I've got my light turned on my phone, and then I'm just going to put the nozzle over that, and then you can see.
Oh, hell yeah. Okay, but how do you take sock off?
Getting your name in lights. Okay, so
0 days without print failure, bro. That's such a fucked up shirt.
But the process is the same for the regular X1. Now, technically, blade of screen and
get to the fucking point, bro.
Or completely unplug it and mister. Move the silicone of the fan and set it aside. Remove the silicone socket.
Okay, so we just need to get our little Allen wrench. I'm assuming this is the right size. Yeah, they standardized the sizes. That's great. And the great thing is that I have a backup with the 0.2. It's just going to be so slow. And I don't think I have the complete assembly, but I do have a replacement 0.4 as well, but I'd have to put it all together. But that's fine. Like, if worse comes to worse. Okay. Was no, yeah, okay. So we can take off the fan. Now we can slide off the sock. How did he get it off?
And set it aside. Remove the silicone.
How? Wait, hold on. Okay, there we go. You just got to be more forceful. I'm always scared about this shit. You just got to get it out. Okay. There we go. There we go. Is this all filament? Does this need to be cleaned? What does a clean hot end look like? Look at this. Is this all filament? This does not look good. Can I just take a lighter to this thing? I'm going to go get a lighter. Okay, so I got some tweezers. But do I have to take off this whole thing? Let's just try a lighter. What the hell? Damn. Let me go inside to do this. I would like to show it on video, but I'm gonna go inside. All right. Nothing stuck in there. A lot cleaner. The thing is, I'm still sort of worried about it being stuck up in between the interface between the outer rim and the actual nozzle. But we are going to see. Also, I burned myself, so wear gloves when you do this. Okay, so I'm just going to put it back together. First, we put on the sock. I believe the sock just goes on like this. But we need to pull this guy up. We need to pull this guy. Fuck. Okay, one side's nice and good, but this side is not. Okay, there we go. The sock is back on. And now we need to put on the fan. But I forget which way the fan goes.
Here's the bent hot end next to the new hot end. Remove the 2 screws, securing the fan to the hot.
I can't even tell. Oh, the label go. Okay, it's fine. And then the cable points up. Okay, all better, hopefully. Okay, so let's reassemble, and then we're gonna finally do our print. I pulled a real strand out of the. I'm very happy that I did this though, because now I'm not so afraid of doing this. Like before, I'd be so afraid. Dude, my gain is just not working. I'm gonna unplug this and plug this back in. Hello? Hello? Why is it? I'm at max gain. I must have done something to this thing. That's so bizarre. I don't know what happened. Anyways, it should be. It's like if I talk like this, it should be freaking real, like the RMS should be like -5. Whatever. Let's go. I forgot the freaking Allen wrenches. What the hell? I think that when I was, so I like took all of the spools out of the AMS, and I think that I got it tangled. I think I untangled it, but it looks like it might still be tangled. What's going on? Salvador! Oh, you've already been in here. Okay. Cool. Yeah, I gotta watch this thing. I'll okay, I gotta go watch this thing though, because this is kind of important. So, peace. Wait, but you can watch this. All right. Oh no. How much did we miss? Ban, bro, ban. How do you ban? Okay. Yeah, so where are we at with this? Basically, honestly, I still, because I didn't take out that outer casing that goes right outside of the hot end nozzle, I'm still sort of suspicious on whether or not stuff is going to drip down from where it got clogged on the inside. But the real test will be if the print after this has any issue, because it was pretty much like, yeah, if I monitored it, it would work for one print, but then the second print wouldn't work. So ay, ay, ay. What a day. I spent 2 hours just fixing this printer, man. But honestly, worth it. Worth it. It was very good that I actually spent the time to ay, 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 bro. How's the print doing? It's got to be doing fine. Yeah, look at that. Okay, so I'm going to go grab it, and then we're going to finally print our real parts. And I'm going to go watch it. Oh yeah, let me ask. Sorry, I've been repairing my three. Okay, I think my woes are over. I think I'm fine. Okay, so I'll get some pistachios. That sounds good.
Okay, should I ask them if they're pistachios or organic as well?
Yeah, if they're not, don't get them.
Okay, sounds good. Okay,
All right, thank you. Bro, if this doesn't work, I'm gonna be so upset. I'm gonna be so upset. Oh my gosh. Okay, that was quite the ordeal. Oh, guys, I found another project that I so want to do. Um Okay. I want to make some stretchy Arduinos.
Here, we present a generalized method to translate two-layer circuits into soft, stretchable forms, enabling the creation of stretchable Arduinos that reliably strain to over 328%.
Let me see if I can steal this paper. Yesterday it wasn't on Sci-Hub, but I think that was maybe just because it literally just got released. Someone give me this paper, bro. That's so annoying, dude. How can this laboratory thing, how can they claim to be like I don't know. They give the air that we're all open and we want to share our research. But then you can't even download their paper. It's like, I just want to read how you guys did it. Because the thing is, look, all they say is by patterning liquid metal paste onto a soft sheet of silicone or acrylic foam tape. That doesn't really mean anything. Okay, let's see. It's about to be done with bed leveling. Oh, well, there's no poop on it, so that's good. I think we're more or less in the clear. All right. We have successfully fixed the 3D printer. Yeah. Successfully. So I'm going to go lock up the shop. And then I think I'm just going to end the stream. Because, like, what else is there to do? Like, after doing that, I'm sick of it. All right. Yeah, that's it. Peace.